This is the Yamaha CR450, and it might just be the easiest vintage receiver to work on. The CR450 was released around 1976 and was the successor to the CR400, which at 16 watts per channel had issues handling the power-hungry, low-impedance speakers that were being released in the US at the time. This unit came to me a couple of months ago, and all I know about it is that it was having some problems with the left channel and that the lamps are burned out. I'm also going to time myself while working on this and give you some tips along the way on fixing your own. If you'd like a link to a full parts list talking about why certain parts were chosen, please like and subscribe, then head to the description where I posted a link to that spreadsheet. Also, check the parts list against your current receiver because some of the parts may vary. Before I start the timer and get into it, I wanted to take a second to appreciate the fact that electricity is invisible. And it's not like woodworking, where you can see the spinning saw blade and know that it'll hurt to touch it. You can encounter high voltages while working on electronics, and you are at risk of injury or death if you don't know what you're doing. So please be careful. Never keep an amp plugged into the wall while you're working on it, unless you know what you're doing and you're only checking for voltages. This is not meant as an exact tutorial on how to do this work, and I assume that you have a basic level of electronics knowledge if you're following along. And on that note, if you do have any questions throughout this video, or there's a topic you'd like a little bit more information on, I am going to be starting a series of informational videos soon, and I'd love to know the topics or the questions that you guys might want to have answered. So please leave a comment below and let me know what you're looking for. And we're off! These receivers are generally easy to work on and fly under the radar due to the low model number and the fact that they were only released in the US. They are a killer bang for your buck and sound warmer than most other Yamaha receivers from this period. Not to mention, it's one good looking machine. Alright, so right off the get, I'm testing for voltages at our speaker terminals. Alright, we're getting 6 millivolts on the right channel and about 6 millivolts on the left channel, so that doesn't seem unhealthy right off the bat. That's in AC, so if we switch to DC, we have negative 6.5, and then we have 5.6 on the other channel. So there's definitely a difference, not looking awful, but the first thing that I noticed in here is that the output transistors, somebody's been in here, they've been working, and they replaced an output transistor that's supposed to be one with a different transistor that's incorrect. Our volume and balance knobs are pretty tied together here. So right channel sounds fine. Ooh, listen to that. It's just breaking up, cracking up, so that's no good. Left channel sounds bad, across the board consistently. And it doesn't seem like this is caused by the controls because it wasn't changing no matter what controls I touch. All right, so we are about 10 minutes into the repair. I guess I'm going kind of slow, but the other thing that we can check is the relay. So we'll do just left channel. The relay seems to not be the root cause of this issue, and it's functioning fine. I've got a hunch we're missing some voltage in the power supply, so let's look at the service manual. To find our power supply, you can look at the board diagram. So this is the board we're looking at. This is mirrored, or it's flipped. So on the actual receiver, basically this would be up here like this. So we can look and find our power supply by just looking in here, and we can see that the labels for all the power supply components are 800 something. So then if we scroll down to our schematic diagram, we can find our power supply by referencing the 800s basically. So you can see right down here, we have our power supply. So we have D803, 805, we have TR803. This is a big part of our power supply, but then we also have our filter capacitors, and it looks like our bridge rectifier right over here. Specifically going to check the voltages that go to these two transistors. And if we go over here, you can see that TR5, 15 and 19 are right here, and the voltages that are supposed to be on them are mapped out. And holding with the trend, this receiver is very easy to work on. As you can see, the whole bottom cover comes off and you have full access to the PCB. And oof, wow, that is potentially the worst soldering job I've ever seen in a receiver that I've pulled apart. It looks like they completely destroyed the PCB on this transistor and the contacts. All right, so based on our schematic, the center leg of each of these transistors is our collector. So we're gonna go ahead and turn this receiver back on. We will ground our lead to the chassis here. See, that one, that does not seem promising. See, it would seem that we're getting no voltage. So we may have a power supply problem. It is on, right? So on the other side, you can see here, we get 32 volts DC. This could just be a case of a bad filter capacitor. It could be a bad rectifier. We're about to find out though. So we have negative 32, and on this side we have 32 positive. So these are putting out the appropriate voltage. We follow our traces here. So for our right channel, we get 32. And our left channel, we are missing, oh, we have 32 there, but we do not have 32 here. There's actually a blown fuse. We need to replace the fuse. But first, I to figure out what's going on with these transistors and probably take them out and test them, because I don't really want to turn this back on, even on dim bulb, with those transistors in there, because they're most likely faulty. Yes, the clock is ticking, but I'm spending some time to do a bit of cable management back here. Put this cable strap on, because having the power cord easily folded up at the back of the receiver is very nice for servicing. It turns out that I do not have any 3 amp 250 volt fuses, as it were, so I'm going to order some. All right, so it's been a couple days. Restarting our timer, we're sitting at 43 minutes, and we've figured out the first major problem with this receiver. Maybe the only problem, who knows? But it's been a couple days, and I've been literally looking forward to removing these transistors and fixing this for the entire time. It's when you work on amps and whatnot, it just, I don't know, I really like this, and so I always look forward to super random parts, but specifically this, just fixing how bad it looks and making it work right. And oh my gosh, there's no thermal paste on the transistors. I mean, why am I surprised with a soldering job like that? But oh my Lanta, dude, no wonder these things are fried. So these are mica insulators, and you need this because the back of the transistor is the collector, and so you don't want that to be grounded to your heatsink. You want there to be some separation. So normally there would be white thermal paste on both sides of this so that you'd have better heat transfer to the heatsink. These transistors may have actually just overheated and caused this problem, or the soldering job caused the problem. Either way, that's crazy. It looks like that may have been what actually happened, because there's a short circuit, so the transistor is actually bad. This looks like it must have been one of the original transistors. It's the 2SD526. You should know. Cat just came in and tried to help me repair the amp. Yeah, so this transistor is bad also. To solve the issue with low impedance speakers, Yamaha doubled the number of output transistors in the amp to 4 per channel and beefed up the power supply. These updates make this amp capable of nearly doubling its 32 watt per channel output into 4 ohm speakers, which is not something you would typically find on a lower end vintage receiver. Alrighty, so off camera I did a little bit of testing on everything. So our 2 bad transistors are over here, and then these other 6 transistors were good. They all tested a little odd, and so not odd, but just not as matched as I'd liked. And then I was thinking about it and I realized that I should just swap all new transistors in, so these are all fairly matched. I am going to keep these old transistors just because they are still good, and if I wanted to swap them in, there was just one bad or something like that, it makes sense to keep them. But in this case, we're just going to swap them all out. It was pretty dusty inside, so I took the opportunity to vacuum and brush it out as best as I could. The plan is to not just replace these transistors, but also to recap the whole unit. And if I'm going to put that much effort into it, then it makes sense to also make it look as new as possible. It'll also be listed for sale, so check the pinned comment for info on that. After dusting, I removed the old thermal paste with a Q-tip and some rubbing alcohol. So this is our new 3 amp fuse. I'm just going to go ahead and put this in right now. Easy peasy. Similarly to my lack of 3 amp fuses, I also didn't have any replacement mica insulators for these transistors or bushings for the screws, which will come to bite me in the butt here shortly, but in the meantime, I carefully washed the mica insulators and wiped them off before applying the new thermal paste to them and securing them to the heatsink. I then got to work prepping the board for new output transistors by removing any excess solder and cleaning each contact with rubbing alcohol. It's been about 2.5 hours, and all I have left to do before installing the output transistors is fix the damaged traces on the PCB. After looking at them, I determined that there was only one that needed patching. Luckily for me, there was an empty hole filled with solder on the other end of the trace, where I could insert a piece of solid core wire to run back over to the transistor. It took me 11 minutes to figure out how I wanted to run the wire, then cut and desheath it and solder it into that blank hole. The other end of the wire will get soldered to the lead of the new transistor. I was excited to get the new transistors thermal pasted and installed, but in my excitement, I didn't quite get the first bushing lined up in the hole before screwing it in place, and it cracked. So I have never had this happen before, and I guess these are really brittle, or maybe I didn't get it quite lined up right because there's a lip that's supposed to go through the transistor. The bushing is definitely in multiple pieces. New bushings are not going to arrive until Monday. Ever the optimist, I figured that, well, I had 7 more good bushings, so I started installing the screws and the remaining output transistors while I thought about my options. You don't need much thermal paste, just a small dot smeared around will do. It's just there to fill any small voids and give the most surface area for heat transfer. As for bending the leads on each transistor, I found that it was easiest to bend them over with your finger or some pliers right at the base of each transistor. This allowed the hole on the casing to align perfectly with the screw hole in the heatsink. I installed each screw partially, then used a set of tweezers to push the bushing down into its place before tightening the screw till it was snug. Sometimes you have to push the transistor around a bit to get the bushing to slide down. Once I got to installing the last transistor, the optimism had worked. and I hatched a plan. So I feel really lucky. I just pulled the top off this Pioneer SX550 I'll be working on eventually. It's the one I did the maple veneer on, and I thought that it used the same output transistors, and as you can see, it does. It uses the 526 and the 596, and they have the insulators on the screws. So in the meantime, because I really want to test this, I'm just going to steal one of these insulators, and then when the new ones come, I'll put one back in here. Look at that. We're in luck. Oh, that one's a little longer though. Interesting. They have a spacer on them. I'll just take the spacer too. That is why it pays to have multiple units around sometimes. You just have easy access to parts. With all of the transistors now secured in place, I flipped to the bottom side to solder them in. To hold the wire in place, I curved the lead around it, then cut it and soldered the lead and wired together. For the rest of the transistors, it was a simple process of trimming the leads, then adding solder to each one. Since the two outputs that went bad didn't have thermal paste, we can assume they shorted out due to heat, which in turn caused the fuse to blow to protect the rest of the amp. So we would be safe to assume that replacing the transistors and fuse should fix the issue. But off camera, I also checked other components in circuit around the transistors to make sure they were in spec and everything was fine. I'm checking the continuity on the transistors, so keep your pen in the center and you can just go to one or the other. No continuity. This is how the transistors are supposed to be. There's no beep when you touch any of those points. And then I got just this wire. This is maybe a little ghetto, but thankfully there was this extra hole there and that worked out. But this keeps the wire nice and out of the way, and we just bypassed this trace. Basically, there's just this tiny trace that they had this soldered to, and I don't really want to solder back to that. It's too close to these. All right, so we're gonna turn this on, and the two places you want to watch are that fuse right there and this bulb back here that you can kind of barely see. And basically, if that bulb is really bright, we've got an issue. If that goes, we've got an issue. Good thing I have more fuses. Our relay's on, our lights are on, nothing blew up, and the bulb is not bright. We like to see it. All right, it has been almost 4 hours, and we've got the issue potentially fixed now, but we're gonna test it here real quick with our favorite song. Wow, this is our left channel now. Perfectly clear. Very nice. Right channel's really clear. All right, so we've got our issues fixed. The next few things I want to tackle are recapping the power supply and putting new lamps in, which is going to be an interesting one. And then we're going to clean the faceplate and knobs. The faceplate is held on by 6 screws, 3 on the top and 3 on the bottom. They're not all the same length though, so make sure to mark which screws came from where. The round knobs pull straight off with a bit of force, except for the balance knob, which on my unit was quite stuck in place. The paddle-shaped rotary controls and the tuning knob use small Allen key-driven set screws to hold them in place. The tuning knob has 2 and they're hidden behind the faceplate. After trying a few ways to get the balance knob off, good old-fashioned brute force won the war. Man, that was a tricky one, dude. The freaking tough one. My fingers hurt. Interesting. I've worked on a CR800 and looked at a CR600, and they always use a thin plastic sheet behind the switch rather than having it built in like this. That's pretty different. There are lots of polishers and cleaners for metal out there, but I found that a wet magic eraser does a very good job of cleaning metal while not removing the screen printing from the faceplate. You still don't want to scrub right on the wording, but going over it lightly won't matter. If the metal looks dull after cleaning, I'd recommend Mother's Mag and aluminum polish. I like to keep it simple. To dry everything off afterwards, I use a microfiber, and to dry the clear dial face portion of the faceplate, I use a fine microfiber for cleaning glasses and such. With everything dry, I moved on to the lighting, and started by removing the tuning meters. The whole assembly is held in by 2 screws, and each meter is held into the plastic frame with a metal rod that can be bent and pushed out. But if you look at this piece, you can see there's 2 green filters for the lights. They're actually kind of bluish, greenish. There's only one LED that lights both these meters. So now my optimism kicked back in, and I knew that there had to be a way to add better lighting to these meters while keeping it fairly easy. Is to just put 2 LEDs in here. I could sand these down and they could fit in there. And these LEDs are special in that they have a 12 volt forward voltage, which means they use 12 volts. So we don't need to put a resistor in line with them, which is really convenient. But what we are gonna do is, since we're putting 2 of them in there to be a little bit brighter, the LEDs will flicker if we're running AC voltage, which this receiver does. Most vintage receivers do for the incandescent bulbs. So if you run them in series, one will be on when the other one's off on the AC sine wave. And so this will help get consistent brightness in these meters without having a flickering. I used 150 grit sandpaper to make both LEDs fit in one of the round holes. If you round over the fronts and sides, it will help disperse the light more evenly due to the extra surface area. All right, so I got these lights working. I got them all soldered in here. As you can see, get light out of both sides for both meters. I used a bit of solder and shrink wrap to hold the lights together. All right, so before I show you what the LEDs look like, I got a little sidetracked and we're gonna replace the filter capacitors. And the reason that I got a little sidetracked is because I got a new tip for my solder sucker that is oval shaped. You can kind of see that. And this is great because for flat pins like this, normally you have to use solder wick and you have to be just very careful. And these capacitors the filter capacitors are glued in place. To get them out, you just want to make sure that these holes are really clean around the pins and that they aren't connected. And there's no easier way to do that than with a solder vacuum. And this tip makes so much difference. It just fits right onto the pin and just cleans everything off. So you can see on this filter capacitor at the top that when I wiggle it, the capacitor is now a bit loose and both pins wiggle. You don't want to push too far one direction. You kind of just want to rock back and forth and be careful of the components that are near them, not to damage anything. So there we go. So negative was facing down. Negative is our little black terminal. There's a little positive indicator up in the top left here, and you can't really see it on camera. That's fine. You'll see it when you pull the capacitor out, and you just want to know that, oh, okay, cool. I pulled out the negative side, and it says that positive is up, and that's how it was. So that's how I put the new one in. If the other capacitor is a little stuck, what you can do is grab a razor knife, sticking with the easy trend, you know? Even if you can just cut the glue on like one side of the capacitor and then kind of leverage against that, that's great. You just don't want to damage the board. It does appear as though this lead is just bent out a little bit, so I'm going to straighten this lead, pull it in, there we go. And out it comes. Wow, both of these old filter capacitors are at about half value, so it's a good thing we're replacing them. Before you install the new caps, remove all the old glue and solder that held them in place, then clean the traces with 99% isopropyl alcohol. I ordered the parts for this receiver a few months ago while ordering parts for other receivers, and I must have gotten either confused or just not looked for the easiest to install capacitors because the lead spacing wasn't perfect on these and there were 3 leads, so I had to cut the extra one off. I've updated the parts list to show 2 options for filter capacitors that will be easy to install. One is a bit more expensive and ups the capacitance to 6800 microfarad, which can help with bass response. I'd recommend adding a small amount of glue to the bottom edge of the new caps before installing them. They're large enough that it could cause issues over time if they aren't glued. I use E6000 or a similar RTV for this. All right, so now that we got the filter capacitors in, a little bit of a random detour, I'm gonna show you these LEDs. The LEDs are on. It's so bad, but like they're on. And this is exactly why I thought the original incandescent was burned out. And I could leave it like this because this is about as bright as it was before, but I feel like we can do better. With just a bit of optimism and a couple hours of time, I got the meters lit much more brightly. We started off with only this one bulb right in here, this one incandescent. I need to clean up these wires here. But basically what I've got going on is there's 2 LEDs wired in series in this section. And then I added LEDs right here in the corners. And you can see the wiring for those goes back to these 2 posts where the wiring for the other LEDs comes from. These are also wired in series. These are warm white LEDs, these are warm white LEDs, but these have the little green filter on them, and it actually looks kind of fine. The light blends together pretty well in the meters, so it's not a big deal. I extended that lead out so that I could run the wires around because the lead was running through here and it just kind of looked bad. So it's nice to have the wires out of the way. I would say that if you were gonna add LEDs to this, the simplest thing you could do instead of doing 2 LEDs in here would be to just add 3 LEDs in series. So you'd have here to here to here and then back to over there. These are 5mm LEDs that I just got off AliExpress. They have a resistor in line with them, so you don't have to worry about adding a resistor or anything. They're just as easy as possible. So the next thing I need to do is replace the dial pointer light. This dial pointer was working fine, but the lamp will burn out eventually, so I'd much rather replace it to match the other LEDs. I'd recommend taking a photo of how the wiring is routed to it also, because it needs to be able to move along the whole dial face and not interfere with the dial string. I used a single 5mm LED that I got from AliExpress, but sanded it flat so that it would fit inside of the casing. All right, I thought I would just show you a quick walkthrough of what I did for the dial pointer. So you can see we've got an LED in there that I've sanded down a ton, and then it has a resistor on this side to keep the current under the heat shrink. These LEDs come with that resistor in place to keep the current below what would mess up the diode. And the LED, I tried to get it as centered as I could, but then I also sanded kind of an edge on it so that the light goes a little bit more that way, even though it's not quite centered. And then the wire for it runs underneath this string back here. And then when I screw this in, the wire will go under this tab and then under this tab on the back as well. And then the wire gets hooked into this so that as this moves, there's plenty of slack on the wire. All right, so the only thing that's not the easiest on this amp is to clean the controls. And the reason for that is that the openings that you would typically spray through are on the bottom of the controls on these. We do have the holes here on the sides of these potentiometers. And basically I just wanted to give you a little overview of, you know, the different cleaners and whatnot. I will be coming out with a full-length video talking about how to clean controls and whatnot. So for potentiometers, I always use Dioxit F100L because it's meant for controls that are not metal-to-metal contacts. So the potentiometers, rotary controls like this, are always the graphite contacts. And if you use something like Dioxit D100L, or specifically what people really like to use is the Dioxit D5, it will degrade, or it can degrade those contacts. Now, what I do use to clean the contacts before I put any Dioxit on is just quick dry contact cleaner. There's a number of brands of this. They're all the exact same. And basically it's just a electronics friendly cleaner that dries really fast and doesn't leave a residue. Whereas if you spray Dioxit D5 all over everything, you're gonna get a sticky residue all over your circuit board. Dioxit D5 and D100L are intended for metal on metal contacts, such as buttons, flip switches, or some types of open rotary controls that use metal contacts. The controls on this unit weren't crackly, but they were likely to develop that issue with use, so I thought it was best to clean these and make sure they're properly lubricated. I can't recommend using the needle dripper bottles rather than the spray cans enough. It keeps your boards nice and clean and gets the concentrated formula only in the spots where it needs to be. Also, I forgot to mention, currently on the time, I've spent about 9.5 hours on this amp. Most of that time so far, over half, was spent on figuring out what I wanted to do with the LEDs. And so if you want to save yourself a lot of time, just do what I did. It's much more simple than I tried the 4 or 5 different configurations of what I wanted. Now that we finished the lights, the faceplate and all, before we put that back on, I am going to do some recapping just so we don't worry about scratching the knobs or faceplate or anything. To me, watching a time lapse of someone recapping a board is the equivalent to watching someone sand a piece of wood for 3 minutes. It's not easy to capture well, and it's the exact same process over and over again. All you really need to know is a few tips. 1. Always double check the polarity of the capacitor that you pull out. Sometimes the polarity shown on the board may be incorrect. Always put the new capacitor in the same way as the one that you pulled out. For bipolar or non-polar capacitors, it doesn't matter. Similarly, if you're replacing a polarized small value capacitor with a non-polarized film capacitor, it doesn't matter which way the film cap goes in. 2. If your capacitor has narrower lead spacing than the old one, don't force the capacitor into the old holes. Use some pliers to bend one of the leads flat, then down to effectively widen the lead spacing. 3. Bend the leads over so that the capacitor is held in place by the bent leads, then clip the leads short and solder them in place. Lastly, I only pull 1 or 2 capacitors at once to avoid mistakes, and I check the receiver for functionality between each section of the device. So in the case of this receiver, that would be checking for no bright light on the dim bulb and a relay click after the power supply and protection circuit. No bright light on the dim bulb tester, and we got a relay click. The preamp and phono stage. And on dim bulb, we get relay click, no bright bulb. I think I can get this bad boy finished within 12 hours. And the main amp. Just a dim light. We get relay click. Look at that. 11 hours and 56 minutes. So that means that this whole recapping portion only took me, I think, 2.5 hours or so, which is pretty solid, maybe 3 hours, I guess, once we get the new transistors in. So with this, I'm not gonna do the tuner. It's just not, the tuner works fine. Seems like there's no reason to touch it. You can throw off the alignment of the tuner by replacing components, so I wouldn't recommend doing that if this is your first recap, unless you want to risk potentially throwing the tuner out of alignment. If it's already out of alignment, then you should probably just do it. One of my favorite parts about a recap is testing all of the caps afterwards to see how many were in need of replacement and where they were. In the case of this CR450, 27 of the 57 capacitors that I replaced were more than 20% out of spec. The sections with the highest concentration of bad capacitors were the power supply, with 5 out of the 7 capacitors being faulty, followed closely by the main amp with 8 out of 12, and the phono amp with 4 of 7 being faulty. Surprisingly, the majority of the low value capacitors in the preamp tested fine, which is abnormal. Usually the lower value caps are the first to go out of spec. If anyone tells you that recapping a whole unit is unnecessary, it's nice to be able to show how badly it needed it. You should always, at a minimum, recap the power supply if you're already in there poking about anyways. So now we'll do these last few transistors. There are 5 transistors that I've identified in this unit as needing to be replaced due to having black corrosion on the legs that will creep into the casing and cause issues. 4 are in the main amp and the 5th is in the preamp, but all of them are the same 2SA763 transistor, which I normally wouldn't replace unless it has black legs. Replacing transistors is much more complex than capacitors, which is why I tested the receiver for sound output before starting to replace the transistors. I know it adds extra time into the process, but if you mess something up, knowing what section of the device you worked on that caused the issue could save you hours of troubleshooting. I'll eventually make an in-depth video on transistor replacement, but for now, what you need to know is 1. Not all transistors have the same pinout, so the transistor you put in as a replacement may either need to have the legs crossed over each other or be installed in a different orientation. 2. A new transistor with the same model number can have a different pinout. 3. Transistors can easily be damaged by heat from soldering, so you have to be fast. And lastly, transistors sometimes perform best if they're gain matched. You can find more in-depth videos about HFE or gain matching on YouTube. I also linked a great video from X-Ray Tony B in the description. Alrighty, so I have the amp back on and we are going to set the bias, or as Yamaha calls it, they refer to it as idling current. And that should be set at 50 millivolts of AC. So on your meter, depending on how it's set, you might have a range of voltages. Volts AC is the waveform over here, the kind of curvy looking one. Mine has a range button, but yours might say like 20K, 10K, whatever. You basically just want the lowest range of that, because we're dealing with millivolts. There's 1,000 millivolts in a volt. Currently we're sitting at 11 millivolts on the left channel, and so we're going to adjust that, and I'm not going to show you exactly how to do this, but you can go to your schematic to see exactly which test points and whatnot. We are right at 50 millivolts, and our other side is sitting at 13.4 millivolts for the right channel, so we'll go ahead and adjust for that. All right, so we got that channel to 50 millivolts as well. We're gonna let this sit for about 10 minutes to warm up all the way. All right, so it's been 10 minutes and that same channel has gone up a little bit. We can live with that, that's great. And on the other side, we're at 49.1 on the left channel. 49.4, that's the same as the other side. That's more than good enough. They were both way too low before. Alrighty, so 12 hours and 50 minutes in, I did a little dilly-dallying and now I've got it hooked up to play some music and it's not turned on. I should probably turn it on, that's usually useful. Our phono section is very, very quiet. Let's see if aux has the same issue. It does. Oh, wait. Ah, there we go. I had it on tape monitor. Nice. So aux works great. Let's give phono another rip. Look at that. All working great. In my last video, I mentioned the music that I'd been listening to during the repair, and I like that. So I figured I'd mention some music I've been really into while working on this. It's an album from Merle Haggard, a classic Bakersfield country musician, called Let Me Tell You About a Song. I recently found it on vinyl while thrifting and have thoroughly enjoyed its live concert style of explaining the story behind each song that he sings. There are some beautiful songs, sad songs, and tales about good people, and you should go listen to it. But back to the repair. Before we listened to this in the living room, I realized that I hadn't cleaned the inputs and outputs on the back panel, so I got to work dusting and lubricating all of the metal contacts and grounding screws with D100L. Then I toted it downstairs for a listening sesh. Right off the bat, it sounded much warmer than any other Yamaha I had heard from this time period. Much more low end. For the price you can get these things at, man, they punch above their weight. And with 13 hours and 39 minutes into this receiver, I'm sad to list it for sale, but I bet the new owner will appreciate it. Thanks for watching.